Good morning, fellow machinists. My name is Frank Zaragoza, and welcome to the first ever Haas podcast. And I'm joined by Andrew and Mark, who I'm lucky enough to work with every day. And on this show, we're going to go over your comments and your questions that you send to us on social media, mostly on YouTube. And so I've asked Andrew and I asked Mark to kind of go through our YouTube videos and pick some comments that jumped out at them. And I thought maybe we could unpack those and just have like a live conversation and see kind of where it goes. So we got a comment from a guy, Marcus Scheffler, and he says on YouTube, great video. There's one more holder system I'm aware of, the Trebos system from Schunk. The holders have 3-lobed bores and are deformed to a round bore by a special hydraulic press. I noticed that there are a ton of comments about this Trebos system by Schunk. What is it about that system that you think people are talking to us about, and why specifically? I know we couldn't get to everything in that tool holder video, but did you look into that, and what are your thoughts?
It's popular. It's another system, right? But it's a funny thing in that it doesn't make full contact all the way around the tool, as far as I'm aware. So it's part of the reason it works so well is because it's making contact with, let's say, 3 points or whatever around the holder. I've never used it before in my life. Not only that, so in real life, right, I used to be a machinist. Now I'm kind of just talk about machining.
I play one on TV.
And that's just a holder I've never used. And so I actually definitely want to give them a call and have it come in. It was that guy that I want to have come in. And then, of course, we always get comments about the SK collets. So we talk so much about ER collets. Then we get grief from people commenting, hey, what about the SK collets, right? So an ER collet, 16-degree included angle. Some of the SK collets, not in Europe, they call like a Cat 40 holder, sometimes an SK holder. So I'm not talking about the holder, I'm talking about the angle on the collet.
Right.
But so they have these 8-degree included collets, which just, when you think about it, come in straight. And so Lindex has some great videos on that where they tighten up the tool and they see how much force it takes to rotate them. And we might do something like that in a video at some point, just to show you the actual holding power between the tools. But there's so much that goes into it, deciding which is the best holder. Part of it comes down to the cost. Maybe it's the range. Like an ER collet might have 1 millimeter of range, where some of the those SK collets might only have a 0.5 millimeter. And so the Schunk, the Trebos, a lot of good things out there that I just don't know about. So that's what's nice about the comments is we're learning a lot about these different holders from you guys, something that we may not have seen.
Yeah, and that makes us on the video team super happy when you get this kind of organic conversation where people are like adding more to the conversation and bringing up stuff. So there's a guy on YouTube, Manny Calavera, and one of the main reasons I chose this comment was because that is the name of a character in a LucasArts game, Grim Fandango, which is like one of my favorite games. So props to you, Manny Calavera. That's a dope username. And he says, one thing you didn't mention is the fantastic properties Weldons have for dampening or disrupting resonance in the cut. Because of the slightly offset tool, this has similar effects of a variable flute and disrupts any possible buildup of resonance, aka chatter. So I wanted to ask you, Mark, why didn't we talk about chatter like in a more specific way? Is that something that we wanted to kind of avoid because we know that there's so many variables?
So that one, we're talking about the tool holder video that was talking about that as far as Manny's comment. Yeah. It's a funny thing too, because we're talking about getting all the tools perfectly on center with zero run out and how that improves your tool life, right? And how every 10th of run out will cause you so much tool life degradation. But what's odd is that sometimes when things are too perfect, they resonate, they hum, and it's this constant balance. And so when you have an end mill that's running off center, he's absolutely right. The thing is less likely to find yourself in a sweet spot where it's going to resonate, and so you might not get chatter.
But you are trading that off against the increased wear on that particular flute, especially.
That one flute is going to get worn out just way faster than the other flutes in that end mill because it's off center. But again, if it's a variable pitch, they try and keep things even that way. But I know that I used to live in San Diego, and there's the San Onofre power plant there, and they just shut the entire thing down. And from the articles that I've read over the years is that they have these cooling tubes in them, and they were machined to a certain tolerance. And everything was fine. The thing cooled, that was it. Well, an engineer changed one number on a blueprint, and he changed the process. So he made these giant cooling tubes much cheaper, but they were actually to a much finer tolerance as well, right? So instead of being held to a 50 micron tolerance, they're now held to a 10 micron tolerance. So not only is it cheaper, but it was a tighter tolerance. And they put all these cooling tubes in, everything was perfect. And then within months, right, they started leaking, coolant where it shouldn't be because these things were so perfect that they had a bunch of tuning forks. They were all perfectly matched and they vibrated and they were so long they started rubbing into it. So the reason that the entire nuclear power plant got shut down was because the tolerances were so tight that everything was so perfect that they resonated with just the flow of the water, and it shut down, and now they're trying to figure out who's going to pay the millions of dollars to tear this place down.
That sounds like the beginning to a tip of the day video right there.
Yeah, the resonance itself is an issue. But so normally you don't get into that problem though with the Weldon shanks because you're not going to be running Weldons at 15,000 RPMs. At that point, you're going to be shaking the machine to pieces.
Right.
So the problems go away. You've got tools that are great at low RPM and they're fine. And then you got tools that are great at high RPMs. And again, the comment on the YouTube video, and we could find it, somebody was saying, that's great, you showed us the balancer, but that's a $40,000 balancer. And I have no idea how much it costs, but it might be. But again, he's right. Normally we're buying stuff off the shelf, we're putting a tool in it, tightening it, and calling it done. So we're buying tools that are rated for 20K, or some that are rated for 7,000 RPMs, like some of the Weldons.
Yeah, there's almost like a your mileage may vary kind of component to almost all these videos. I'm remembering another comment where a guy was talking about how he never machines a flat into any of the tools.
I saw that comment.
And
the guy's wrong, by the way. There's two things going on there. If you've got no flat on your end mill holder and you've got a carbide end mill, nice hard end mill, right? And you're holding that in a Weldon holder and you're cranking on that thing. Maybe if you have an 1/8" end mill, it's fine because it's got so little load. You put a 5/8 end mill with no flat on it and a Weldon shank, and if it's not spinning on you, you are going way too slow.
Right.
You are taking you're not working hard enough because you should be making that thing cry.
Well, you should be pulling it out.
You should be pulling it out. Yeah, if you've got no flat in a Weldon and your tool's not pulling out, you're doing something wrong. Right. You're not pushing it hard enough.
So do you think if you do have an end mill and it is off center in a Weldon shank tool, and you have worked that one flute hard enough to wear it down, do you eventually just end up using the other flutes as the first one wears down to match the diameter of the other ones?
Yes and no. Possibly, solid carbide. A lot of the problem is, especially if you're running on harder material, is you've got coatings that are only a couple tenths thin. And so what you've done is you just wore through the 3/10 worth of coating on that one edge. And once that thing's going, it's like a ceramic tile on the space shuttle. You've lost the heat resistant ceramic tile on the space shuttle, the coating on that one flute. And if you're running on hard material, it's going to blow. You're going to lose that flute. It's going to explode.
Not just gall, but or maybe it's very quickly gone from galling to
if you're running on aluminum, stuff like that, sometimes just a little bit of worn out end mill is okay because it actually stops chatter. If it's too sharp, it sometimes bounces a little bit, right? We used to grab pennies, a long time ago, and score the edge of the end mill, trying to wear it out a little bit so it wasn't so bouncy and sticky and chattery. We don't do that anymore. The grinds on the end mills are much better. So now you just pull them out of the box and run them. But on aluminum you don't care. But on some of the other metals, your loads go up so high, and just bad things happen quickly.
We should mention that there's a pretty cool chatter video that the video team Mark put together. Released a year and a half ago or so, a couple of years ago maybe now. We should put a link up to that because that's got some great information in it as well. So Andrew, do you have any comments you want to share with us? Something that jumped out at you?
Yeah, there's some interesting stuff here. We did this video about the auto parts loader. We have done a couple of them actually, and one of them had Luke, one of our accountants, setting the machine up, and essentially was just set up to show how easy it is to set the machine up. And there were a number of comments that talked about how people were worried that the auto parts loader was going to replace operators and stuff like that. I've got a couple here. Vlad Rubika said, so why spend 4 years in trade school and 35 years on machine shop floor to be replaced anytime by Boses from the accounting department, ?
Thank you for the snarky comment, Vlad. You get a shirt.
It doesn't have any sense to me. And another Tuco, Breaking Bad.
Nice.
Then his response was, don't tell me you spent 4 years in trade school to learn how to load parts. This will allow you to use your skills you've learned at school more efficiently while the machine loads parts for you. Work smarter, not harder. That's, I think, going to usually be our approach to this question is the whole reason you have a CNC machine tool to begin with is to do things in an automated fashion and to go faster than you can when you're manually loading a manual machine. Setting the machine up and programming the machine and setting up the tooling and specifying what tools you're using and making more efficient programs, those are all things that you will continue to do despite having an APL or a robot loading your machine.
So, you guys spend lots more time in a machine shop than somebody like me behind the camera guy. As a kind of a CNC newbie, what is the prevalence of APLs and robotics? What would you say percentage-wise?
What time is it now? So we're at 9:54?
Yes.
And there'll be a certain percentage of the market that's using automation. And by 9:55, that number will have changed. There has been a just seismic shift in the number of people. You can see it on Instagram. Everyone's like, Ultra Savers, J.D. Allen and those guys. They're always showing, Kevin, their UR robot that's loading the lightsabers into the chuck of the machine.
Yeah.
They didn't have that 5 years ago. And a year ago, they just had one robot. And today, they probably have 2 or 3. And shops are doing this all over the place. And so if your job can be replaced by a robot, it's not the job you want to be doing.
Right.
What you want, the job that you want is programming that robot. You want to be the guy, measuring the parts or inspecting or programming because you're going to make $5 an hour more than just the guy who loads the parts. So there's no loss there.
Right.
I'm not worried about automation replacing all of our jobs because just like every other new technology out there, it's just going to make available for us, the fun jobs, the things that we want to do.
Yeah.
And I've mentioned this before, but like one of my favorite little stories was this guy Milton Friedman. He was a Nobel-winning, economist. Yeah. And so back in the 60s or 70s, he writes in some of his books that he was somewhere in Asia, which means whenever somebody says somewhere in Asia, it's probably an airplane story, right? Didn't really happen. But anyhow, he writes about this, and everyone quotes his story that he was going through a construction site and for a works program somewhere in Asia, and everyone was digging a long trench with shovels. And he was looking at this, and he's thinking, hey, this is the 60s or whatever. Why do you have, 1,000 guys here digging this, long site with shovels? Why aren't you using bulldozers? And the foreman replied and said, well, it's a works program. The whole reason this job site exists is to create jobs. And so Milton looks at the guy and says, well, then why don't you give him spoons?
Oh.
Right? If you want to just create jobs, we can make work for ourselves.
Yeah.
But you're not going to make any money at it. And no one wants to dig a canal or whatever or a job site with spoons.
Right.
Right? We want to drive tractors. Tractors are cool.
Yeah.
There's a lot of fun things we can do. You're not going to stop the process here and the progress.
Yeah.
Right.
Whatever, 20 years ago, 10 years ago, 30 years ago, the longer you go back, automation was more difficult in those days, and it took a larger volume of parts to make it worthwhile. You were setting up a very dedicated process in every case to make automation a reality. And now you can very soon now you're probably gonna be able to get a robot in front of your machine for not that much money that you can set up very simply from one of our controllers or even one of our competitors' controllers, and you can be automating your process like that. And the easier it is, the more people are going to do it. It's like any other kind of technology. So it's going to be commonplace very soon, I think.
There is a plug and play component to the software, and we've made it really easy with templates and all that stuff, but there is still a little bit of a learning curve to get that up and running.
Absolutely.
And if you can get good at that process, that's also going to be a skill that's kind of in demand.
Yeah.
I think.
Using the robots, both from the software side and from the, you still have to make jaws for it. You have to make any kind of special fixturing. You have to make sure it stays in alignment. There's lots of different things that are still required.
That's a good comment.
It doesn't run itself forever.
It's hard, but it's fun. It's fun hard, and you get good at that, and you make more money.
This is from Daniel Brown. surely the time it takes to set this all up, you could have been halfway through the job already. So I guess I wanted to tee that up for you, just to ask you what you learned when you're going through the setup of the APL. What do you think about, the templates and how easy it was to use?
Frankly, when I went down to start playing around with it, I didn't have high hopes for it being as easy as it turned out to be.
Yeah.
It's still involved. There's a lot of things you need to set, because you realize that you're telling the machine, you're defining a lot of positions for it. You're telling it where to pick up the part, where to move above the machine to be aligned to the door, because that can change, of course, as your part size changes. Right. How far to come down in the machine, where to rotate inside the machine. Those are all things that vary as your parts varies. Right. So you have to control them. Therefore, you have to set them. It takes some time to do that. What's cool about it is that once you've set up a program for a particular part, the next time you go to program a part that's got a similar geometry, much of that of the numbers that define where you're traveling in space are already set.
Oh, yeah.
Nice.
You can take that
You're
program
one thing.
and changing a few things.
You're not starting from scratch.
You're not starting from scratch. So it makes it, the second part is considerably faster than the first one. Mm-hmm. Plus the first one's going to take you a little while to get through. Mm-hmm. And then from there, I think it I don't know if you'd say exponentially, but it definitely is much quicker the second and subsequent times.
Oh, I could see that. Yeah, if you're just running even 10 parts, and once you've learned that system, you're running it every day. After a couple of weeks, even for 10 parts, I would rather just go jog it, click, beep, and hit the button and go than sit there and load them all. You're going to get better and better and better.
I'm not sure where that number is, but maybe it's 50 parts, maybe it's 10 parts, maybe it's maybe it's 100
bar
parts.
Feeder guys, the bar feeder guys, they might say, well, I'm just going to, when I pull it out and set my stock, run the button, pull it out, set my stock, run the button. No. After no time at all, they learn the G105 software programs, and they just run the bar. They just run the bar feeder on every single job. It's a couple numbers, one little change. The same thing is going to happen with the APL. And I'm excited for the mills because it's going to be the same way, right? You're going to have this robot or whatever, APL, and we have some other things coming, robots as well, that load the thing in the vise. I see a time, and it's not that far off. I mean, I'm talking like 6 months from now, a year from now, where people are going to be loading first op, the wide open jobs, first operation parts in a vise in their mills in the same way that people do with bar feeders. And that's going to become the more common way to run things. It's just too easy not to. It's going to become so easy.
Yeah.
And is it one of these things that once you use it, you really don't want to go back to the old way, right? When you have to run a lot.
Oh, yes. I've heard that exact sentence, 1,000 times, and it's always from the probe guys. Right?
Yeah. As soon as you whip, you're like,
and then a month later, don't take away my probe.
This is easier, actually.
Yeah, it's just easy. Yeah. I don't care about from the operator's perspective. I don't care that it's faster, easier, saves money up. Like it made my life easier.
Yeah.
My day was better because I had that whatever probe in the thing. Yeah. Same thing with probes, TSC. I always preach that because it made my life easier as a machinist. My days were not as bad when I knew that my drills would not explode because I had TSC. Having a drill explode,
anything that's going to make your tool live longer is you reloading that tool and reprobing it and resetting and everything that many fewer times.
Yeah.
I'm going to draw crazy but sort of semi-related parallel to we've been doing videos at Haas for quite a while, and there was one time where we were anti-teleprompter. And then we were just like, you know what, let's try it. And we kind of grumbled about it and we set it up. And every actor, every on-talent guy is different. But it's a piece of technology that you look at and you're like, this is going to get in the way of my process. It's kind of like a monkey wrench in the process. I don't really think this is going to help my workflow. And then once you do it, you're like, oh my God.
It is the same thing. You got to learn. It's a different technique. And in some respects, you'd think it would be absolutely the simplest thing in the world because now you're just reading it instead of having to memorize it.
You guys are really good at delivering dialogue and making it seem natural, and that's a huge talent. That's a skill.
See, Mark is great at essentially improvising on the spot.
Yeah,
and I'm not that way at all.
Me either.
So if I wanted to say my dialogue the right way, I either have to memorize it forever or look at the teleprompter.
So the APL is the teleprompter for the machine. Is that what I think that's what we're saying.
That's it. You got it. That's right.
That's a reach.
That's right.
Never
Yeah,
mind.
all right.
We're gonna cut that out for sure. Mark, what do you got? What do you got for us?
So when you mentioned doing this, right, we're going to sit down and talk. You're like,
Yes.
hey, talk about some comments. My mind just went in some very, very odd directions. Originally, because we just did the video on tool holders, I thought about the Eagles comment. You know, Eagles are the most overrated. There's a little blip in the video, and we can show you guys that. But over the years, we've just had some fantastic comments. I've got them right here in front of me. Let's see here. Pokio's video I loved. Well, of course, I've got here. You recognize this one, Daniel Machado
Let's
from
talk
Brazil.
about Daniel Machado, man.
How do you talk about comments and not mention Daniel Machado?
That's right.
We should send him a box of shirts.
I know. I have no
It's
idea
a shirt
who
for
he
every
is.
comment ever.
Yeah.
But for years and years, he's commented on just about every video, to the point where if we don't see his comment, what do we see?
We have,
Where is he?
other
Where'd he
people.
go? People are afraid for his safety.
Yeah.
Send somebody to help this guy out.
Check out with
Check his
Daniel.
pulse.
Yeah, send someone to his house. Something's gone wrong.
Yeah. Man, we should just say thank you to Daniel Machado. Thank you, Daniel. We
Yeah,
appreciate
it's
number
terrific.
one
Thank
Haas
you, for
YouTube
sure.
channel fan.
We've got other ones here. Let's see here. The tapping video we just did, you and I did. It was a great video. We had a lot of fun doing it. And one of the favorite comments on that video that I just love, I like, but at the same time I feel badly because some operator lost his job because of this video.
Yeah.
And it's a little sad. And so this was, let's see here, Desi Quintero. He wrote a couple months ago. He wrote, "Awful video. My boss fired me on the spot when he saw me playing with a snowplow and artificial snow all over his shop. Thanks a lot, Haas." And so,
I didn't see
Sorry
that
about
one.
that.
yeah, sorry about that. So we had a snow plow in the beginning. It was showing which way the chips are going to move. But we make videos like that we spend a lot of time on. And on the other end of the spectrum, when I sorted my list of the videos that we've done together, tapping video was at the top, right? Most views. And then, 80-something videos. Way down at the bottom, we've got these videos that have no views whatsoever, right?
Relatively speaking.
Relatively speaking, right?
Yeah.
And so I've got, we all have those videos. But I'll see these comments on some of these, like the one we just did on Pokiokes.
Yep.
Pokioke means mistake proofing. We're using the probe to make sure the thing's loaded right, especially if you've got an APL or who knows, you want to verify before it runs. You can Pokiyoke in your program and have the probe make sure everything's cool before it runs. But we got comments in that video saying lifesaver. We were literally trying to find a way to Pokiyoke some of our jobs. Thank you. This was engineered to detail on that video. And there's just a ton of those videos on the macro hacks video and the in-process probing video. Comment after comment, this is the video we were waiting for, thank you. And those videos on the macros and that type of stuff and the probing, like no views comparatively.
Yeah.
1.25 million, 16,000.
Yeah.
Right? So it's like, why do we spend the time and effort to make a video that's going to be on macros, that's going to show you some weird code to probe? But I love it because those are my people.
Yep.
It's
Yeah.
a guy stuck behind a machine, and he's got to find a way to do this, and he can't find an example. And so I'm just thrilled that Mr. Haas, that Bob Murray, that Scott Gassage, all these guys allow us to make.
Yep.
Yeah, we're
I don't
not
wanna
just
call it a bad
making the
video,
heavy hitter
but
videos.
it's not a crowd pleaser.
We're
I guess.
super lucky, blessed to be able to work for an organization that has this like pay it forward attitude about education in general.
Yeah.
And YouTube in general can be kind of a vitriolic, kind of trollish place. When it comes to certain kinds of videos, we are super lucky and we recognize that there's an amazing, uncommon ratio from the likes to dislikes. And I mean, nothing could make us happier than that.
Yeah.
That's amazing.
You can focus on the topics that aren't going to get amazing views because they're important to machinists out there, and particularly as you get into advanced topics, the stuff that you usually want to deal the most with. You're often not talking to a huge audience,
Right.
Potentially.
The audience
Drilling
gets
and
smaller
tapping,
and
of course,
smaller.
is everyone uses those. Almost anyone that does any kind of work on wood or metal or anything
But I'm excited about using pound 3026 to define what tool in the offset table.
That even is.
So you can write a macro, and that's the tool in the spindle, and that's awesome.
Yeah. If you find a video that answers a question that you have in your mind at that point, it's like a little miracle. You're like, what is this weird stream of consciousness? I had this problem, and then boop, there's a notification where a video came up exactly answering this problem I had. Like, that's amazing.
That's what everyone's looking for on YouTube.
Yeah.
That's why it's probably my favorite thing to watch now, because whatever I'm doing, whether I'm changing a part of my car or I'm installing gutters in my house, someone is doing it and is going to tell me how they think it's best done. And you look at the variety of videos and pick the one you think is best. And I remember I was looking for how to rebuild the fork seals on my Yamaha dirt bike, and the instructions weren't very clear in the manual that I had, and so I was searching on YouTube for someone taking one of these things apart, and I found this guy in his beat up looking shop, but he was doing the work on his tabletop there in his vise, and I was just I searched through the video for 30 minutes, finding that one spot where he took that particular seal out, and I watched how he did it, and it allowed me to finish the crucial part that I needed.
The crucial part, the missing link. And with CNC machining, a lot of people look and they say, oh, we'll figure it out. But when you're writing the code for a CNC machine, you cannot have a missing link. You can't be 95% correct. If you're missing the 5%, the machine won't run, or worse. And so we've sat down, right, over the last couple of years, and whether it's John Nelson or Marcus or me or you or Brian, somebody's making a video on each one of those links, the things that could cause you pain and grief and keep you from getting those parts made. And so we're making all those, and we have a list of a couple more videos that we know we're missing.
A couple hundred, or a couple thousand, maybe.
In fact, so you were talking about the comments. So right now we should just say that if you write a comment on this video with a suggestion. This is not a suggestion of what color should I paint my car, but what thing do you really need to know on the Haas machines that only Haas could tell you, maybe, whether it's on the lay of live tooling or cutter compensation or G1, 2, or 3. We don't know. You tell us, and we'll see how that gets bumped up, and that really does affect maybe what video comes next.
Cutter compensation.
Yeah,
there's a deep rabbit hole to jump into.
We can cut that out. We'll do an easier video with G1, and we'll do a G1 code, and we'll do that video.
Do you guys feel like there was a point? It's almost like we've crossed into this other phase of education and training with social media kind of leading the charge, where there used to be this idea like, I don't want to share my secrets with other people. I want to kind of keep stuff to myself because that makes me, I don't know, it gives me an advantage over another guy in a shop or something. And the social media revolution in YouTube has really like blown the lid off of that. Like we've discovered maybe through this technology that when we lift each other up and we help each other, it makes us better.
I felt that tinge when we first started making the videos. When I was answering phones, right? I was answering phones like all the rest of the apps guys. And so all the other apps guys trained me and told me what I needed to know for Haas. I was a machinist for years, but that's different than knowing the settings and parameters and stuff. And so there's this little thing, like if I write this down and show this information to the world, I'm less valuable. And I tell you, even though I felt that, I started writing everything down. And I started writing down notes, and I started saying, look, if I'm the only person in the room that knows this, or that wrote it down, everyone knows it. But I'll send it out to everyone so they can just send out this sheet. And so I didn't lose my job.
Right.
Do you know what I'm saying?
Yep.
If you're helping other people get better, then
you've got a job.
It is evident on YouTube that now people are kind of almost getting self-worth via training other people, instead of holding on to this closely guarded secrets, so that they are better in whatever industry or whatever walk of life they're working in.
Yeah, and as a video guy, I always go back to this, it takes a little team of people to put these together. There's a whole lot of behind the scenes stuff that goes on. These two guys especially can speak to the writing process and just the amount of research that goes into every video. Andrew has this thick file folder for the really in-depth ones where he's got, he needs to know the subject inside and out. It's that old I think it's an Einstein quote, right? If you can't describe it simply, you don't understand it. So that's really one of the biggest challenges for us in unpacking some of these complex things.
Yeah, well, we've certainly talked about this a 1,000 times, but we've come to realize that I think almost always you can never be simple enough.
Right.
We'll keep trying to simplify things and make them understandable to as wide a group of people as possible. And sometimes we've thought this is too simplistic, and people are just gonna think we're idiots.
That's
because
hard.
We're breaking it down to such a basic level, and that hasn't been the reaction at all.
Oh man, we had a conversation yesterday. Brian and Andrew and I. We were talking about this other video that it's probably going to be released before this one is. And it's just about these simple 9 lines of code that you can do to write a program. And we were talking about it's too simple, it's whatever. I'm like, no, but the reason that it excites me is because you take these few lines of code here and these few lines of codes here, you can do everything.
Yeah.
It's not just that this is this, it's like we didn't start with the simple codes and just make a video on the simple codes. We painstakingly, over hours and hours, decided, look, with just these codes, you can do just about everything. So start here first.
Yeah.
But the list didn't just populate itself. We didn't just choose the easy codes and put them on there. We chose.
Yeah, you didn't pick the first 9 codes in the manual.
Yeah, it takes hours and hours. We can explain anything because we've been doing it for a while. We can explain anything in an hour. Start the camera, we can explain it.
Yeah.
And that would take an hour to write. If we want to do it in half an hour, that takes 4 hours to write. If you want to get that thing down to 5 minutes, you've got tens of hours in there, hundreds of hours. Who knows? Depending on the topic.
That's a great way to describe
the shorter the video gets, the more time it takes to concentrate.
And you get that description or that explanation that seems really simple, and you're like, oh, that's the best way to describe that.
When it seems obvious, or it seems like you almost already knew it, that's usually when you realize, that's probably a pretty good definition.
A snowplow for the
snowplow
chips.
Okay, because you shot it.
Yeah.
So the snowplow video, we wanted to show the chips going one way or the other, and we talked about it and stuff like that. But what we don't see in the video is that I had ordered 5 different types of cheese cutters, cheese slicers off Amazon and elsewhere for that video. Now, what does cheese slicers have to do with which direction the chips go? Well, I thought that if I took a knife and I held it up against a block of cheese and I went like this with the knife, that the cheese would go this way or this way. It turns out that it doesn't work that way.
Yeah.
The cheese is too soft and it's going to keep going the way it wants. So it didn't relate to
Cheese is not like metal.
Cheese is not like metal. But it didn't slice, it wouldn't move the way we wanted it. And so I had cheese and we were going to make a little cooking show and stuff like that. And at the end of the day, we're like, it's a bad analogy. It doesn't make sense. What does make sense? And we went with the snow and the snowplow.
Cutting room floor, man. See YouTube community what Mark and his family ate 2 months of cheese sandwiches just to get this video for you guys. I hope you enjoy it.
Cheese on everything.
Yep. Thanks everybody for watching this Haas podcast. Hopefully we'll do some more. Keep on commenting. Keep on giving us your questions. We love reading that stuff, and we read almost every single one of them, or somebody on our team does. And I do also want to give a shout out to the rest of our video team. Super hardworking, talented, professional video editors, John, Sal, Rick, and Tyler. These guys are really getting after it and making great stuff. So keep on commenting, and we're going to keep on making great videos. If you want to reach out to us, if you have questions or comments, drop them down there in the comments section, or we can send an email to tod@haascnc.com. That'll get straight to Mark. That's the tip of the day email address. And a special thanks to the community. Thank you to the subscribers. And keep on watching. We'll keep on making videos.
Oh, yeah. Like, subscribe, comment.
Yep.
Thanks.
Thanks, guys.